Alright, hello guys. Once again, this is Coach Garcia. This time we're doing the Quadfun test review. So we'll go in, we'll work all the problems. If your teacher hasn't already told you, the Quadfun test for this unit has very, very little partial credit. So either you know it or you don't. Once again, very little partial credit, so make sure that you count every single problem and consider every single problem whenever you bubble in your answer or whenever you circle your answer. Alright, first we start with number 1. What are some attributes of the linear parent function of a quadratic equation, and what is the equation of a parent function of a quadratic equation? Alright, so we start with the parent function. Some attributes of the linear parent function. I don't believe we need the attributes of a linear parent function. I think this might be a typo. What are some attributes of the parent function of a quadratic equation? I think this is what they meant. The parent function of a quadratic equation. What is the equation of the parent function of a quadratic equation? So basically, my parent function of a quadratic equation, this part right here, that's going to be y equals x squared, or you may also see it written as f of x equals x squared. So you might see it one of those two ways. So that's my quadratic parent function. Just a few attributes. If we go over to the table, we can go ahead and start listing some of these things out. So my vertex will always be at 0, 0. And these are things that you kind of want to memorize. So vertex at 0, 0, it opens up. In other words, my parabola looks like this. We can also say a few symmetric points. Sorry, 2 M's. Symmetric points would be something like 1, 1, negative 1, 1, 2, 4, negative 2, 4, and 3, 9, negative 3, 9. So again, all of those points coincide with one another. So there's 1, 1, there's negative 1, 1, there's 2, 4, there's negative 2, 4, and there's 3, 9, negative 3, 9. Right, so those are all my symmetric points. Now we can go in, we can also say domain. Domain, or the x values that it spans. Again, the arrows at the top means that the parabola keeps going. So it keeps going, so eventually it'll span the entire x-axis. Eventually, if the parabola keeps going. So my domain will always be all real numbers unless I don't have the arrows at the top. My range, or my y values. You basically, so now we're sort of measuring our parabola using our y-axis. I see that my lowest y value that my parabola will ever reach is going to be 0. And the highest number that it'll ever reach, again because of the arrows at the top, will be infinity. So this will basically say y 0, and my y values will always be bigger than 0. So bigger than or equal to, or in other words, greater than or equal to. And again, that's just a few of the characteristics. I guess we can go one more and say axis of symmetry. I'll write it over here. My axis of symmetry for my parent function will be this line, right? It always goes through our vertex. My axis of symmetry will be x equals 0, aka the y-axis. So again, these two things match up. That's as much as I can really say about the quadratic parent function. Those are just a few things that we can list. Next, number 2, write the range of the following functions in words and using the correct mathematical notation. Alright, so now we look at range. So we're looking at range. Obviously, you want to figure out what range is first, if it's x or y. In this case, my range will always be my y values. So we're looking and we're measuring, really we're measuring our parabola using our y-axis. So we're using our axis that goes up and down. So we're measuring using the axis that goes up and down, or in other words, my y-axis. So we basically want to answer two questions, which is what does it span and does it keep going? So first, and really I don't see arrows here, but even though I don't see arrows there, I can most likely assume that this parabola will keep going. And then now I just want to find my vertex or my highest point. In this case, it's going to be 4. Now the way I always write my equations is I'll go ahead and write down y. I'll leave a little bit of space, and then I'll write the number, so the y value of that number where my vertex is, or where my highest or lowest point is. So in this case, the y value is 4. So I write y and then 4, and now we just figure out, are my y values bigger than that 4 or smaller than that 4? Well, we see that my parabola opens down, so I can see that all of my y values will indeed be smaller than 4. And really you can, if you had a table on this, or if you start plotting your points or listing your points, you would see that all of your y values, none of them are 5, none of them are 6, none of them are anything above that. All of my y values would be smaller than that 4. So I have y, I leave a little bit of space, I have 4. So it's going to be less than or equal to, because it can also be equal to 4. So this is my range written out in the correct mathematical form. In words, if we're using complete sentences, this would be y values. We can just go ahead and say smaller than 4. Y value smaller than 4. Sometimes they'll use things like real numbers, like all real numbers smaller than 4. In fact, they might replace that with real numbers, not all real numbers. But they'll replace that with something like real numbers smaller than 4. Alright, number 2, or part 2 of 2. Once again, I want to measure my parabola using my y-axis. So I want to measure using this axis. Again, because we're doing range for all of them. Once again, even though this doesn't have any arrows, I can pretty much assume that this parabola is going to keep on going. So now I look for my vertex. My vertex is at 2, 1. So this basically says that my lowest y value, in this case if I trace it back, is that 1. So none of my y values will get any smaller than 1. Again, because my parabola opens upwards. So if we're doing this mathematically, that would be y. Again, I look at the y value of 1, and now I want to ask myself, do my y values, are they bigger or are they smaller than that 1? If I look at my y values and I look at where my parabola is going, it's going to be reaching all of the bigger numbers. So my y will be bigger than or equal to that 1. And again, in words, I can go ahead and say something like, let's just go ahead and change up our wording just a little bit. This would be real numbers bigger than 1. And again, I changed up my wording because you won't always see it as y values. Sometimes they'll just say numbers or real numbers. Bigger than a certain number. So again, this is the mathematical term, and this is more or less how you'll see it in an actual sentence. Alright, and then finally we get to this one. This is still technically a parabola, so my parabola goes up, it starts coming back down, and then before it can reach all the way back down where it should, where it's sort of symmetrical to the other side, it just stops right here. Alright, so we have two things here. We have a closed circle and an open circle. That's something that we haven't talked about in a while. And then we also have sort of the parabola coming up and then kind of coming back down. So we have to figure out what we're talking about. So once again, we're doing our range. So we're doing the y values. So we're doing the ones that go all the way up. and all the way down. So we're basically measuring sort of like the height, if you want to think about it, the height of the parabola. Alright, so one difference between this parabola and other parabolas is that this one does not keep going forever. So it gets to that point and it stops. It gets to this point and it stops. It's not like these other ones where it just kind of keeps going. These actually stop. So I want to list my points from least to greatest, so from smallest to biggest. So I basically start on my y-axis, I go to my lowest point, and I trace that across. So the lowest point on my parabola so far is this. I trace that across and I look at my y value. My y value is -5. I go ahead and write that down first. What I like to do, or what I teach my students, is to skip a little bit of space and then write your biggest value. So if I look at my parabola, and one of the biggest mistakes that students make is that they go to the end. So they'll say, there's my end point. But you're not looking at endpoints, you're looking at highest value. So what's the furthest to the top that your parabola goes? So the furthest to the top that it actually goes is 4. So it's, like I said, it's not your end value, it's the highest point that it reaches. You want to sort of think about flattening this out. If you were to flatten it out, the highest point that it would get to would be that. Alright, so skip a little bit of space, and I go ahead and write down the 4. In between this, I want to write down the value that I'm talking about. So in this case, we're talking about range. So we're talking about our y values. So I go ahead and write down the y in the middle. Oh, come on, autofocus. Sorry about that. Alright, so I write my y in the middle. I write my inequalities always point to the left. I teach my kids the Beyonce song. Irreplaceable, if you want to go look it up on YouTube, since you're already on YouTube. But both my inequalities point to the left, and then I basically just check my endpoints and make sure that they're both included. So a dark shaded endpoint, that means that it's less than or equal to at 5. So at that 5 I have a solid line, or a solid dot, so that's less than or equal to. And then same thing up here, I don't have a hole, basically. I don't have this sort of point there, so that can also be considered a whole number, or a shaded in part. So I have -5 less than or equal to y less than or equal to 4 as my final answer. Or in words, that would be real numbers bigger than -5, but smaller than 4. Something like that. It would be written something along those lines.